Is there a structured way to win a game? When you're making choices alongside another person, what's the best strategy? Economists use game theory to help make decisions in many instances, including when you're making decisions simultaneously. I'm Yana Gallen, assistant professor at the Harris School of Public Policy at the University of Chicago, and this is Economics for Everyone. There are many kinds of markets. Some are easier to study, like markets with one big player or many small ones. But markets with just a few really big players can be more difficult. Game theory can be used to study situations where the payoffs of one agent depend on both their actions and the actions of others. It's the study of these strategic interactions. Game theory isn't just about competition between firms. It's used by economists, political scientists, and sociologists to analyze a variety of problems, from negotiating to voting to penalty kicks in soccer games. There are three key elements to any game: the players, who are those involved in the game; the strategies, which are the plans describing how a player will act; and the payoffs, which is what each player will get given each scenario. In addition to the three elements, when thinking about games, we have to consider the timeline of each action. What is the order that players play? In game theory, there are simultaneous move games and extensive form games. Simultaneous move games happen when players pick their actions at the same time. A simple example would be rock, paper, scissors. Each player chooses their move at the same time. The prisoner's dilemma is also a simultaneous move game. In extensive form games, on the other hand, the order of play is specified. An example of this would be a game of chess with two players, Francesca and Charles. Francesca makes her decision, and then Charles observes her decision and makes his decision. The goal when playing any game is to determine the equilibrium, set of equilibria, or non-existence of equilibrium. The equilibrium in a game is the set of strategies, a complete plan describing how a player will act that results in no player wanting to change their strategy given the strategy chosen by the other players. We call a strategy combination a Nash equilibrium if each strategy is the best response to the strategies of the others. The very idea of equilibrium, however, depends on two factors. One, that all players understand the game and the payoffs associated with each strategy. And two, that all players understand that the other players understand the game. How do you find a Nash equilibrium? Well, imagine there are two coffee shops, yours called Cup of Joe, and your competition, Uptown Roasters. Both you and the competition are deciding whether to advertise, and the decisions are made simultaneously, making this a simultaneous move game. After doing market research, you construct a payoff matrix. The process for finding Nash equilibrium in simultaneous move games, like this example and the prisoner's dilemma, is finding your best strategy for any choice of your opponent. This strategy will be the best response to the strategies of the others in the game. If taking the other player's strategies as given, it gives you greater payoffs than any other strategy you have available. To find a best response, you need to ask yourself, in every cell of the payoff matrix, what should I do to get the greatest payoff? Since you're making your best choice given all their choices and they're doing the same, no one has any incentive to change. When you agree, you're in equilibrium. What's your best response if Uptown Roasters advertises? Looking at the payoff matrix, it's clear your best response is to advertise as well. Looking at that cell, does either coffee shop have a reason to change its strategy? The answer is no. If Uptown Roasters changed its strategy, it would earn less. Likewise, if you changed your strategy, you would earn less. Because of this, both shops choosing to advertise is a Nash equilibrium. Neither have incentive to change their behavior. What if instead Uptown Roasters chooses not to advertise? Using the same reasoning as before, your best response is not to advertise. Once in this cell, do either of you have incentive to change? No. So in this particular game, there are two Nash equilibrium. You advertise and Uptown Roasters advertises, or you don't advertise and Uptown Roasters does not advertise. Let's consider another example. This example captures the tragedy of the commons, which is what happens when common pool resources are dramatically overused. Let's picture two firms that both operate near a river, Firm 1 and Firm 2. The profits of these two firms depend on whether they pollute and whether the other firm pollutes. This is captured by our payoff matrix. Following the same process as before, each firm is better off if it pollutes, regardless of the other firm's choice. Unlike before, this game has what's known as a dominant strategy equilibrium. There is a choice that is always better, no matter what the other player does. The dominant equilibrium in this case is to pollute. Each firm is choosing what is best for themselves, even though if they both chose not to pollute, they could make more. And both they and society are worse off. Game theory doesn't always lead to what is best for firms or the world. It's simply a tool that provides ways to examine situations when the payoffs of players are intertwined. The problems addressed by game theory are faced by many corporations and individuals. You now have the tools to explore these problems, because economics is for everyone.